Welcome to today's lecture on Introduction to Manufacturing. Today's topic is metal identification. So you're in a manufacturing setting, chances are you could be dealing with some sort of a metal. Maybe the subassembly, you may be making that subassembly, maybe even just dealing with the raw material going into that product that you're manufacturing. So you kind of have to have some ideas about the metals that you're dealing with. Today we're going to do just a very brief topic of metals. We're going to talk about some items you should know and a few tests that you can do real quickly to see if that's something that, see what type of metals that you're dealing with. So we'll go right into some metal terms. Having a basic understanding of different types of metals present in the shop environment or manufacturing environment is very important to be an efficient worker. Because if you're trying to deal with aluminum and you keep going over and picking up carbon steel, you're not going to be very efficient. But the difference between aluminum and carbon steel is going to be easily to be found, to be seen, so that you shouldn't make that mistake over and over if you kind of know some of the rules behind it. Many metals have been distinguished by their physical properties such as color, weight, internal structure, or even surface appearance. Simple tests can be done to aid in a craftsperson in metal identification. Metals can be classified either as ferrous or non-ferrous. And we'll cover those, what each one of those are in a second. Material handling of metals will vary by company according to the company's standard procedures and policies, and sometimes quality control. A ferrous metal is a metal that contains iron. Even though that it may have other elements or other metals added, it has iron in it. So anytime that you know of iron, it's ferrous, no matter how much iron is there. The properties can be altered to meet specification. Some of those includes cast iron, carbon steel, as well as the typical tool steel that everybody kind of uses for tools and generic steel making. Then you have the non-ferrous metals, which do not contain any type of iron. They're usually non-magnetic. It means that the magnets won't touch them, and they're more resistant to corrosion. Since they don't have the iron aspect to it, they're more resistant to corrosion. Include aluminum, brass, and copper. Continuing with metal terms, pure metal is a single element metal. Pure means that there's nothing else added. It is just that type of metal, so there's nothing really else added. But if you have a mixture of two or more, then it's called an alloy. And alloys are created when specific properties are desired that pure metal does not exist. Sometimes you have aluminum alloys. A lot of the cars that we have, the rims on the cars, you want lightweight, but you want strength. So you have an aluminum alloy to make up your rim. Ferrous metals can include mild steel, which is the most utilized ferrous metal. It is composed of 0.15 to 0.3%. That is not 15%, that is 0.13%. That's a very small amount of carbon with iron. Carbon steel is composed of, you have mild steel, then you have carbon steel. And carbon steel has a little bit more carbon. It's 0.5 to 1.5%. Carbon steel is extremely tough, allowing it to be hardened and tempered. Steel, which is a form of iron, contains somewhere between 0.03 to 1.7% carbon. Just a generic common term called steel will fall into that range. Then you have stainless steel. It is an alloy of iron, nickel, and chromium, which it's very high resistant to corrosion, since the properties of it allow it to be tough, as well as stain resistant and or corrosion resistance. So hence the name stainless steel, since it's very hard to actually stain, and it's very tough. So stainless steel is kind of how the name came about. 6 types of metals. There are 6 types of tests for metals. We will only discuss the magnetic and the spark test, but there are others, such as appearance, fracture, magnetic, chisel, spark, and torch. You'll see in the videos, if you watch the videos of the magnetic test, which is attached, please go and watch that video. You can kind of see the appearance of each one of them, such as looks, the sheen, maybe even the feel. and the weight. If you're holding the difference between aluminum and the high carbon steel, you will be able to see that there's a difference in weight there. That's kind of all falls inside the appearance. The magnetic test uses a magnet to see if the metal has an attraction. A strong attraction is usually an iron alloy or a pure iron of some sort, pure nickel, stainless steel, or carbon steel. A slight attraction could be called what they call a mono, which is high in nickel alloy. Then you have non-metallic metals such as copper, aluminum, some zinc, and some other precious metals such as titanium. You'll see that on the magnetic slide as well. So go over and look at the video on it's only a few minutes long, on the magnetic test of different types of materials. Another test that we have is the spark test. It is a simple identification test used to observe the color, spacing, and quantity of sparks produced by grinding of the metal. Spark test requires some practice in order to have reliable results. Because if you're worrying about the pressure on it, if you put too much pressure on it, you're going to have too much sparks, and then therefore it's not going to show off the material, or you're going to have not enough pressure on it, and you won't be able to have enough sparks to show off the material either. So it kind of takes a little practice to get it right, and you need to make sure you're using the same amount of pressure for each metal or each type of material being used. Of course, determining the grades of the metals by spark test is just not practical. So looking at a low carbon steel, which is a 0.3% mild steel, will produce sparks in long yellow-orange streaks that may erupt in the white fork sparklers. And this is kind of what you see when it's being sparkled off. And we're going to show the video in a second, so we'll kind of go over this. Medium carbon steel is 0.3 to 0.6%, exhibits increased forking from low carbon, produce a wide range of spark lengths and are more near the actual grinding, which means that they're closer, they're not so far away, they're closer. Then you have carbon steel, produces an increased amount of bright yellow-orange sparks. High carbon steel has a lot of carbon in it, 0.6 to 1%. And then you have aluminum. Aluminum doesn't create any sparks at all. Stainless steel will give off a few little sparks depending on how much carbon is in that. And you'll see in the video, the stainless steel that we have has very low carbon. You can kind of see very, very few sparks. And then you've got copper, which does not create any sparks at all when tested. So, okay, we're going to move over to the video, and we'll start the video up. The video online will have some music and some talking there real quick. So there's the grinder that we used for the video. We did some practice to make sure we got the pressure down right. And the first one you see is aluminum. And of course, if you listen to the video, it's pretty loud, so you can't hear me talk about it. But aluminum, you don't see any sparks, do you? And then the spark that you probably saw was something that was on the grinding wheel itself. So no sparks. That's just kind of the characteristics of aluminum. If you also, it's very sheen. It's also pretty light. Okay, here you're talking about mild carbon steel. Mild carbon steel is, you see the orange to yellow sparks with the white sparklers. See how far it goes off? You can see the sparklers going there. I'll get a handle on it in a second. You kind of see it. But you can see the white sparklers, white fork sparklers at the end. You can see them right there toward the end there. Nice forks. Next one, stainless steel. Should have very few sparks. You can see it there. There's not as much as the other ones. It all depends on the type of iron content that you have. But you can see here, very little sparks, long red streamers, long orange and yellow streamers with very little forking on the end. Very typical of stainless steel. All right, next you have copper. And you can see there, pretty much nothing there, right? Copper does not create any sparks when tested. The little sparks that you're seeing are probably metal residue that's left inside of the grinding wheel and coming out as we apply pressure with the copper, but there's nothing, no real sparks there. Of course, you can see it by appearance too, that it is copper. All right, here's a high carbon steel. Produces increased amount of red and orange sparks. Look at that. You can see the increase of it. Definitely there in the middle of the plume. and then it's got the white sparklers in there, but it's the volume. You can see the volume from the mild carbon steel is much increased. The amount of there in the middle of the sparklers are much greater. Titanium. We don't really talk about titanium much, but look at this. Titanium, wow. Bright white sparklers at the end. Very dynamic, very easy to identify titanium from any other type of metal. Really pretty easy to make that determination. Hey, that is titanium. You won't be quizzed on it. There's nothing on the exam on it, but I wanted to show titanium. Of course, you see I was able to secure a small little piece for our demonstration today. Okay, so that's our spark test. Moving on to our metal terms. We really want to get into some stainless steel. Stainless steel is a big metal that you'll use in manufacturing, especially because of its properties. It's tough to corrosion. It's hard to stain, but it's still very durable. Now, but keep in mind though, that stainless steel is more expensive than normal tool steel or low carbon steel. It is very expensive, and sometimes it's not found in manufacturing because of that, depending on what's being made. But typically, if somebody wants a product to last, they're going to use stainless steel. And if you do, I want you to know that there's different types. There is the austenitic, which is created by adding nickel or manganese and nitrogen. This type also has the ability to be welded and formed. It is most frequently used, which is the most frequently used type of stainless steel there is. Then you have the ferritic. It's chromium-based. Ferritic steels possesses a minimum less than 10% quantity of carbon, and have a similar microstructure to carbon and low alloys. Given the absence of the toughness in welds, ferritic steels are suitable to use in thin segments only. And then you have, of course, these words don't get any easier to say. You have the martensitic. Like ferric steels, martensitic steels are chromium-based. However, they contain a greater level of carbon, usually up to 1%. Duplex, they're half of ferritic steels, they're 50%, and then the other half of it is austenitic stainless steel. So duplex steels have a higher strength and are resistant to stress, corrosion, cracking. Precipitation hardening, pH, is the addition of copper and aluminum, which creates a pH steel, which has a very high strength level. So today we've gone over understanding of metals, trying to find ways that giving you some basic terms to help you in manufacturing. This is just a small little tidbit that we have in our course. The videos are there to help you. You should have a video for a magnetic test as well as the spark test. But look at while you're doing that, look at it and you can see the types of appearance. You'll be able to see the different types of appearance, from smooth to rough to a gray to a shiny color, and to a copper, and then of course to a titanium. So you'll be able to see different types of metals right there. Should help you gain a long way. The information here today should help you with also your exam and your quiz that you have at the end of the lecture. So good luck with